Hello friends, today we are going to see join creation operators. It will help us to combine multiple observables and emit values. I have also done a separate video on creation operators. Please check it out if you have not already. So I will try to explain all the join creation operators with examples so you will not forget easily. So straight away we will go to the today's topic. So first we will see combineLatest. So combineLatest is one of the join creation operators. So it allows us to merge multiple streams. So this is stream 1 and this is stream 2. This is input observable 1 and input observable 2. It allows us to merge multiple streams by taking the most recent value from each input observable and emitting those value to the observer as a combined output, that is an array. So if you see, we have multiple input observable. So here we have input observable 1 and input observable 2. What it will do is, like, it will combine the most recent value from each observable. So if you see here, at this point the most recent value is 1. For input observable 2, there is no recent value at this time. So on the second observable, we are getting the value A. In this time, input observable recent value is A. Recent value of input observable 1 is 1. So it combines to give us 1A. Okay. So this is why we call this as combineLatest. So we are combining latest value from each input observable. If you don't get value for at least one observable, we will not emit any values. Only if we have any value for all the input observable, only then we will start emitting the values. So after this, whenever we get value for one of the input observables, we will just emit the most recent value from each input observable. So when 2 is emitted, the recent value is of input observable 1 is 2 and most recent value of input observable 2 is A. So we are getting 2A. At this point, the most recent value of input observable 1 is 2, but most recent value here is not A, it is B. So we are getting 2B. Similarly, when C is emitted, the most recent value is 2 here and the most recent value is C here. So we are getting 2C. Likewise, we are getting 2D and here 2 is updated to 3. So the most recent value is 3 now, not 2. So we are getting 3D, 4D and 5D. So once all the input observables is complete, the output value is also completed. So the resulting stream completes when all the input stream completes and will throw error if any of the input observables emits an error. Okay, this is very important operator, so we will often use it in our Angular project. So there is one catch here. So imagine if a input observable 2 completes before start emitting any values, you will not get any value from input observable 1. Okay, so that we have to be very careful. Like if the input observable 2 completes before emitting any value, you will not get any value in the observer. So this is one catch. There is another scenario also, like you might not get value for one input observable, that is, you are not going to get any input observable input value in input for input 2 observable. So if you don't get any value and it just complete, you will not get any value in the observer also. Okay, even though you are getting value in input observer 1, you will not get any value because there is no latest value for input observable 2, no latest value. Okay, so there are two scenarios, like if there is no latest value in input observable, one of the input observable, you will not get any value. And again, if any of the input observable completes before emitting any value, you will not get any value in the output observable. Now we will see one code sample. First we will see the code. So here I took two observables, so observable 1 and observable 2. So first this is a, so I've done a separate video about this operator, timer operator. So I add a link. So what it will do is like it is same as interval operator. If you pass two parameters, so first parameter will delay the start time, like interval means you will get the values like 0, 1, 2, 3 after the mentioned seconds. So if you mentioned 2000 here, every 2000 millisecond you will get one value. If I put 1000, if I pass 1000, I will get value for each second. So this first parameter will just delay the first process. So the observable 1 will start after 1 second, and the observable 2, that is second timer, will start after 3 seconds. There is a delay we intentionally gave to check how the combineLatest operator is working. So we are combining both the observables into connect stream observable, and we are subscribing to it. Then we will see how we are receiving the value. So I will refresh the page again, so you will see how the console is coming. So before combining anything, I am just printing one console, like to know the start time. So at 49th second we are printing the console. So we are getting the second console only by 52nd second. That means only after 3 seconds we are receiving the first value. But if you see here, after 1 second itself we are trying to emit value from the observable 1, but we are getting an initial delay. We will see how this is working in a diagram. So first value, so 49th second, so just we are subscribed to two input observables. So after 1 second we are getting value from first observable. Okay, so let the value be 0, but at that time you are not getting any value for the second timer, so it just goes, and you are not getting any value from the observer also. After 2 more seconds, like at the 52nd second, you are getting value for the second timer also, and as we know, we will get the latest value from each observable. So we are getting value 0 and 0. Okay, value of first timer is 0 and second timer is 0. At the same time, this 2000 second is also passing, so we will get value of 1 here from the first timer. So value emitted, so again we will get another value as 1, 0. Okay, so only you are seeing the 4 consoles here. So first console is 0, 0, and second console is 1, 0. After 2 seconds you will receive value 1 and 0. Okay, so sorry, 1. So you are getting value as 1, 1. Here we will get value as 2 because there is a 2 second timer here. Since we are getting only 2 values, it will not consider this one. Okay, you will not get any value here. Only 2 values will be emitted. So 0 and 1. So if you add it 2, so take 2 is controlling the number of emitted values. So only we are printing the console first timer 1 and second timer 1. I hope this code example is helpful. We will see the second operator now. Now we will see concat operator. So you might have heard this name concat in many places. So usually we will use in JavaScript, we will use it to concatenate two strings. So if you have two strings like hello and world, you can concat by using plus operator or using the inbuilt JavaScript library, JavaScript function concat. So as the name suggests, it is helpful to concatenate two inputs. Similarly, we are going to concatenate two input observable. So here input observable 1 and input observable 2. So how we are going to concatenate is, first we will subscribe to, so at a time it will subscribe to only one input observable. Only after one input observable completes, we will go to the second input observable. So if you see here, the first input observable will be subscribed first. So it will emit value as 1 and again it is emitting value 1. So at that time we will not consider the second input observable because it is yet to be subscribed. So then we will get values as 1. So then it gets completed. So first subscription is completed. Then only we will start subscribing second input observable. So now we are getting 2. So here we are printing 2. Okay. So this is how we concatenate two input observable. So first it will concatenate first input observable, then it will concatenate second input observables. So it combines input observables by sequentially emitting values from observables. It has only one subscription at a time. Once the current active stream completes, it subscribes to next observable in a sequence. So it will sequentially emit values. So this operator will be very helpful if order of emission is important. So in real Angular application, usually we will use this concat operator. If one input observable will get value quickly and second input observable might be taking some time. For example, first input observable may be some catch, okay, and second input observable may be some network call. Usually you will get a response from catch quickly than a network call. So in this scenario you can use concat operator to subscribe to catch first, then go to the network call. So if order of emission is important, you can use concat operator. So we'll see the code example now, so you'll get more idea. So we'll see the code example for concat operator. So as we saw in the previous example, we are going to give two input observable to concat operator. So this is observable A and observable B. So we are using interval operator. So this interval operator will emit values for the given duration. Like for every 1 second we will get values like 0, 1, 2, 3, like that. So and we use a map operator to identify the value is coming from which input observable, whether it is coming from A or B. To identify that, we are using the map operator, and we are using take operator to control number of emitted values. So we will get only 3 values from the observable. So now we subscribed. So I will refresh the page. So we will see the observable output of the observables. So if you see here, first it is printing only values emitted by the observable A, not observable B. So only after the A observable gets complete, it is starting to emit B observable. So as we already saw, this concat operator will subscribe to only one input observable at a time. So it will sequentially subscribe. Only after the observable 1 gets complete, observable 2 will be subscribed. So only we are seeing values of the input observable A first, then we are seeing the values of observable B. I think this example is helpful for you. So use concat operator only when the order of emission is very important. Now we will see forkJoin operator. Now we will see forkJoin operator. So this operator is little bit different. It takes a number of input observables and waits for all the observables to complete. Once all the observables complete, it emits the last catched value of each input observable. So for example, so this is observable 1 and this is observable 2 and this is observable 3. So this forkJoin operator cares only about the last emitted value of each input observable before it gets complete. So it will just ignores all other values. It cares only about the last value emitted from each input observable. So if you see here, you're not seeing any values here. You're seeing only after all the input observable gets completed. So this observable 1 completes, like observable 3 completes first, and observable 1 completes second, and observable 2 completes third. Only after all the input observable completes, it emits value of catched value of last emitted value. So the last emitted value for input observable 1 is E, and the last emitted value of input observable 2 is J, and the last emitted value of observable 3 is 4. So it just catches all the last emitted value, and it will just see like whether all the input observables are completed or not. Once this condition is met, it will just emit last emitted value of each input observable. So only we are seeing EJ4. So this forkJoin operator is similar to promise.all. So usually you will use this promise.all operator to trigger multiple HTTP requests and get response only after all the requests gets completed. Like if you are triggering 3 or more requests, you will get a response randomly, like first request will complete sooner than other 2 requests, but still this promise.all will help us to get response at single time. Only after we get response from all 3 HTTP requests, we can do some operations with the responses we get from all 3 requests. It might be many things, like we can trigger more than 3 also and less than 3 also. So this forkJoin is similar to promise.all. So now we will see one example for forkJoin. So this is example of forkJoin operator. So inside forkJoin, we are trying to trigger 3 HTTP requests. To trigger a HTTP request, we are using AJAX operator. So this AJAX is also a creation operator from RxJs. So it is similar to http.get, which we use in Angular. So using AJAX operator, we are going to trigger HTTP request, and here we are passing the URL for all the HTTP requests. So here we are trying to get users of Google, Microsoft, and just user list. So response time might be different. For one request we will get at 1 second, and second request we will get at 2 seconds, third request we will get at 3 or 5 seconds. So only after we get response from all the HTTP requests, we will get the output. So usually it takes the longest one. Like if user's HTTP request is going to take 5 seconds, we will get the output only after 5 seconds. Now we will see here, maybe we can see a network call also. So if you see here, we are triggering 3 HTTP requests, and this time might be different, like everything is triggered parallelly, but first one completed sooner, like it took only 4 milliseconds, but other two took 6 milliseconds. So this response of Google, right, it waits till other 2 gets completed, only then we will get the output. So now we get the consolidated output of all 3 requests. So this is an example for forkJoin. Now we will see merge operator. Now we will see merge operator. As the name suggests, this operator will help us to merge more than one input observable. So from multiple input observers, it will emit values concurrently. It will look like we are getting values from single stream. If order is not important, we can use merge operator. So if you see here, we have two input observables, observable 1 and observable 2. And here we are getting the output. If you see here, we are getting the values concurrently. So whenever we get values, it will not wait for anything, it will just emit that value. So only we are getting the value the same time the input observable emits. So A is emitted, immediately we are getting the output A here, and D is emitted after some time, and we are getting the output at the same time. So it is not going to wait for anything, it will emit values concurrently. So if order is not important, you can use merge operator. So when you want to listen to more than one observables and do some operation without any particular order, you can use merge operator. So for example, you can audit user interactions. Maybe some input observable one can be some button click, and input observable 2 can be some form events. So both we are going to do some action over these events. So on button click events or form events, we are going to audit the operation. In this kind of scenarios, you can use merge operator. So whenever user clicks a button or change the form state, we can easily do some operation over that action. Instead of handling it separately, we can use the merge operator to do that action. We will see one code example to understand more about merge operator. Now we will see example for merge operator. Here we have two input observable, observable A and observable B. For each observable, we will get value after every 500 millisecond. So it will get values like 0, 1, 2, 3, 4. So to identify from which observable we are getting the value, we are using map operator to append A before the value and B before the value for observable B. And we are interested only the first three values. So we are using take operator to take only first three values. So here I will refresh the screen. So if you see here, we are getting the values concurrently. So first we are seeing value from observable A, second we are seeing value from observable B, then A, then B, then A, then B. So we are getting values concurrently without waiting for anything to complete. So it is exactly opposite to concat operator, where we have waited for one observable to complete before starting to subscribe for next observable. In merge operator, order is not important, but in concat operator, order is very important. So this is an example for merge operator. Next we will see race operator. Now we will see race operator. So as the name suggests, it is race between multiple input observables. So race is used to select an observable sequence that is the first to produce values. As soon as one of the sequences starts emitting values, the other sequences are unsubscribed and completely ignored. So we have multiple input observables, like we have three input observables, each emitting series of values, but we are interested only on the fastest one. So which one is the fastest one? So if you see here, second input observable is the fastest one, because we got the first value from the second input observable before we get any values from the first and third observable. So using the race operator, we will subscribe only to the second input observable and we will unsubscribe the first and third observable. So only we are seeing values from only from second input observable, not from first and third observables. So this raise operator can be used in a places where we have to send request to multiple data sources and consume the first one that sends the result. So in that case of scenarios, we can use raise operator to identify which data source is the fastest one and subscribe to that particular data source and unsubscribe the remaining data sources. In that kind of scenarios, we can use raise operator. Now we will go to zip operator. Now we will see zip operator. So this zip operator combines observable streams in a way that resembles the mechanism of zipper. So if you imagine zipper, we have teeth. So we have teeth on each side. So the teeth on one side will be joined by teeth on another side. Like it will join parallelly. It will join the exact opposite one, not the other one around. So first teeth of A and first teeth of B will be joining. Similarly, second teeth of A and second teeth of B will be joining. So this zip operator resembles the same mechanism of zipper. So if you see here, we have two input observables. This is observable 1 and this is observable 2. So it will emit the fresh value. So if you see here, 1 will be emitted and we are not emitting the value directly. So it will wait for the second input observable to emit. So it is emitting value A. Now we have one fresh value. So we are sending both the values as a couple like 1A, like we have in zipper mechanism. So it is always sent in a tuple. So now we got another value in a first observable. It is 2, but we are yet to get any fresh value in the second input observable. So it just wait till we get any fresh value. So now we get the fresh value B. So we are emitting 2B. Now the second observable emits another value C, but we don't have, so we are not emitting anything. So once 3 is emitted, C and 3 are fresh values, so we are emitting 3C. And 4 and D are next fresh value, so we are emitting 4D. So first observable emits value 5, but we don't have any fresh value to be emitted with 5, so we just ignore the value 5. So the rate of publishing will be dictated by the slower of the two sequences. So if you see here, observable 2 is the slowest one comparing to observable 1. So whenever we get the value in the observable 2, it is published. So up to this place, second observable is a slower one, but after that second one is the faster and first one becomes the slower. So now the first one dictates when to publish the value. So here the first observable dictates when to publish the value. So the zip operator, always the slowest one dictates when to publish the value. So now we'll see one example to understand how it is working. Now we'll see one example for zip operator. In this example, we are listening to some events. So whenever that event is triggered, we are passing the current time at which the event happens. So in the zip operator, we are trying to listen to two events. One is mouse down event and another one is mouse up event. And we are trying to measure time between mouse down and mouse up events. So in this place, zip operator is very useful. Like we are listening to two events at the same time, but only after two events get complete, we are going to do some operation. In this case, we are measuring the time difference between mouse down event to mouse up event. So here you can see I am going to click the document, that is a mouse down event. So I'm just clicking it now. I'm yet to release the mouse. Here I'm not seeing any console, but I'm going to release my mouse. That is a mouse up event. Now I'm seeing the console. So I pressed the mouse button for some 13,192 milliseconds. So in this particular scenario, zip operator is very helpful. Like it waited for second event to complete and then emit the result so that we can do our operations. We will see another example to understand zip operator clearly. In this example, we have 4 input observables and we are trying to replicate the scenario where we will get values at a different point of time. Here the source 2 observable will get value only after 1 second. For source 3 we will get value after 2 seconds. Source 4 we are getting value at 3 seconds. In some scenarios, it is not meaningful if we get value for only one observable. We have to wait till all the source observables gets completed. Like we have to get response for all the source observable to get the value. We have to wait till we get response from all source input observable before printing the console. So this is a requirement here. So as we already saw, slowest one dictates the rate of publishing. So in this scenario, the slowest one is source 4 because we added a delay of 3000 millisecond. So I will refresh the page and see which one dictates the rate of publishing. 1, 2, 3. So the slowest one dictates the rate of publishing. So source 1 we got value hello immediately. World will be received after 1 second. Goodbye will be received after 2 seconds and world will be received after 3 seconds. But it waited till source 4 gets completed before it send all the value to the output observable. So this is an example for zip operator. So thanks for watching my video. Please like, share and subscribe for more videos.